Hi students, thank you for joining in on this final review. I'm going to post this document as a PDF. So after you watch the recording, you're going to notice that there's a lot of links to practice problems or tutorials or other helpful websites. So you can access these by opening the PDF file that I will post next to this recording in the user links widget and also in a news announcement. So first of all, let me make it clear that this is going to be my physics class A final exam review. But if you are in physics AB, there's going to be two different review videos. So you need to watch this one because it covers the first half of your class. And then there will be a second recording that you need to watch as well. Again, that's for physics AB students. If you're physics A, this is your review session for the final exam. So here are some final exam details. You will take the final exam anytime after 12:01 a.m. on Wednesday, December the 7th through Thursday, December 8th at midnight, basically 11:59 p.m. Please do not wait till the last minute to take the final exam, because if you start it before the deadline but submit it after the deadline, it is still considered late. So please make sure that you give yourself plenty of time to complete this exam from beginning to end. So the exam questions will be about 45 questions long. It's a mix of multiple choice, fill in the blank, matching order, etc. You will have 90 minutes to complete the exam, and you must do this in one sitting. Final exams will not be reset because you pause the exam and try to come back later. So please make sure when you sit down to take the exam, you have 90 minutes blocked off with no interruptions. There will be questions from each unit, more details on the next slide, and your final grade will be released on Thursday, December the 15th. I cannot and will not tell you your grade before that date. Instructions on how to view your final grades are in the handbook. So a lot of students want to know what they made on the final exam or the final of the course, but I am not allowed to give that to you until December the 15th. So please do not email me and ask, because I politely will say no. So for my physics A students, so AB students, just kind of tune out for a second. Here is the breakdown of your questions. From the first unit, Math of Physics, there's going to be 6 vectors, 6 questions, linear motion 8, Newton's laws and projectiles 8, forces 8, momentum and energy 8, and rotational motion 6. Alright, so here is important, make sure you can see it all, announcement. It says, I understand that technology does not always cooperate, so please make sure the following before starting so you can avoid as many glitches as possible. If using a portable device such as a laptop or tablet, make sure it's plugged in. So even if the battery is fully charged, maybe something happened and all of a sudden the battery starts giving out, just better safe than sorry, plug in the device. Also, if something happens while taking the exam, take a screenshot of your computer screen and immediately email me the screenshot. You should do this by pressing your button on your keyboard as PRT screen. Some examples below. If you receive an error message or timed out before the time is up, an image is supposed to be there but isn't. Typos that make the question impossible to understand. So these are just some examples. If something happens that does not involve your computer shutting off, take a screenshot. If you do take a screenshot, send the whole image so I can see the date and time. Typically students do not have any problems with the final exam because it's been set up that way, but just in case, those are your instructions on what to do. So here we go into the review. Unit 1, so this is the Intro to Math of Physics. So here are the subtopics. Make sure you know graphing, unit conversions, scientific notation, measurement errors, accuracy versus precision, and significant figures. You will also need to know standard unit conversions such as seconds in a minute, minutes in an hour, and days in a year. Here are some examples. I want you to try these on your own and then check your answers online using this tool. So this is our first example of a link that you can use. So again, you can access these links in the PDF that I'm going to post underneath the recording in the links user widget or the news announcement. Scientific notation. You need to know the following. Make sure you can convert the standard notation to scientific notation. Make sure you can convert number from scientific notation to standard notation, rules for adding and subtracting numbers in scientific notation, rules for multiplying and dividing numbers in scientific notation. This was definitely one of our weaknesses when it came to the quizzes and tests. If you need some review, here are some sites below for extra practice. Khan Academy, which a lot of you have asked me for extra help, I always send you there. They have great tutorials. Here's another one, colorado.edu, so you can practice a few and then you can check your answers following that link. So again, guys, I am not going to be able to do examples from every part of this class in this review, or we would be here for 7 hours or longer. Okay, so make sure you look at this document after I post this video. Alright, so continuing with significant figures and digits. So these are not the same thing as scientific notation. A lot of students got that confused. So here are some things that you might see on the exam. You might list the number of scientific numbers in a digit, round a number to the appropriate number of significant digits, add, subtract 2 or more numbers, and report the answer with correct number of significant digits. Identify whether or not zeros are significant in a given number. If you need help with any of this, please click this video, which goes over a recap of all of these rules. And actually has a little bit about unit conversions as well. Unit 2, which was vectors. So here are some subtopics. Vector concepts, distance over displacement, vector problems in 1 dimension, or vector problems in 2 dimensions. A rule of thumb is when you read a vectors problem, the first thing you should do is sketch a picture of what's happening. This will help eliminate the following mistake. So look at these 2 problems. A car is driving north at 50 miles per hour and encounters a wind blowing south at 10 miles per hour. What is the car's resultant velocity? Problem 2. A car is driving north at 50 miles per hour and encounters a wind blowing east at 10 miles per hour. What is the car's resultant velocity? If you just read through these problems for the numbers, you might solve them the same, or your setup would probably look something similar like below, that picture below. However, if you go back and read the problems, you will see that they are very different. If you use setups shown on the previous page, you're doing way too much work for one problem. Let's look at problem 1 again. It says a car driving north at 50 miles per hour encounters a wind blowing south at 10 miles per hour. What is the car's resultant velocity? This is an example of vectors in one direction only. So this is the 10 mile per hour simply gets subtracted from the 50 miles per hour, so your final answer is 40 miles per hour north. So again, remember, since we're doing vectors, don't forget the direction. Compared to problem number 2, says a car is driving north at 50 miles per hour and encounters a wind blowing east at 10 miles per hour. What is the car's resultant velocity? This is an example of vectors in 2 directions. You have to use the Pythagorean's theorem to solve this problem. Additionally, you will have to solve for an angle. For more practice on this, visit this website. So again, make sure you read the vectors using directions. Here are some vocabulary words that you need to be familiar with. If a question asks for a resultant vector, velocity, displacement, etc., you should be providing a number or a magnitude and an angle direction. A lot of y'all forgot about the angle. So if a question asks for magnitude of a vector, you just solve for the size of the vector, see the previous slide, and don't worry about the direction or angle. So make sure you understand what the question is asking. If a question asks for the components, that means that you were given an angle and a resultant, and the problem wants you to provide the vertical north-south y-axis leg or the horizontal east-west x-axis leg. If you need some review with vector problems, check out that video or this video. Unit 3 covered linear motion. Some subtopics include motion graphs, linear motion concepts, concept velocity problem solving, linear motion with acceleration concepts, acceleration problem solving, free fall problem solving. When you see these concepts, think definitions, units, situations, when x doubles, what happens to y, and use formulas/equations. A lot of your virtual labs in this unit covered those concepts, so make sure to review your virtual labs. Always pay attention to what's going on the y-axis when graphing. For the red graph, distance over displacement is on the y-axis, so the slope represents the velocity. For the blue graph, velocity is on the y-axis, so slope represents acceleration. Horizontal lines, distance divided by time is an object not moving, and velocity over time is an object not accelerating. So make sure you understand what those graphs are talking about. I did an excellent review on this. You can watch that recording in the user links widget. Unit 3, constant velocity. If an object is not speeding up or slowing down, we can use the standard speed velocity equation, which is speed equals distance over time. So here are a few problems that I want you to read, so you can pause this video, try to take notes, or if you're trying to take notes, you can pause it and try to solve those two problems. And if you want me to check your answers for these two problems, just send me an email and I'll be happy to take a look at it. Next topic is acceleration. When problems have objects speeding up or slowing down, we have to use the following formula. Acceleration equals final velocity minus initial velocity divided by time. So look at the following phrases. If it starts from rest, that tells us that the initial velocity is 0. If it comes to a stop, that means the final velocity is 0. Here is a practice quiz that you can take on acceleration. Kinematic equations. What if the object is accelerating and the question asks about distance? So don't forget there are other motion equations you can use. Also, you do not have to memorize these formulas. You can use them on the formula page that you can download on page 1 in Unit 1 that you can print off and use on your final. Free fall problems is just a fancy case of acceleration. The key is to remember that long as we are on Earth, we know acceleration is 9.8 meters per second squared towards the center of Earth. Sometimes, again, remember problems around this to 10, but for our case, always use 9.8 for the final exam. These problems can seem like they don't have enough information, but usually a lot is implied. A ball is dropped from a height of 10 meters. How long does it take to fall? We know that a negative 9.8 meters per second squared. We also know the height is 10 meters. So if the ball is dropped, it started at rest, so the initial velocity is 0 meters per second. So take a look at these kinematic equations and see what you can use now. If you need more practice with free fall problems, be sure to click the link here. Moving on to Unit 4, Newton's laws and projectiles. Here are some subtopics that you need to make sure you can understand. Different forces, Newton's first law, Newton's second law, Newton's third law, projectile motion concepts, and projectile motion problem solving. So let's review the 3 laws of Newton's. The first law is objects will keep doing what they are doing until a net force is exerted on the object. This is why we wear seatbelts. Newton's second law, force and acceleration are directly related. Mass and acceleration are inversely related. So the two formulas are force equals mass times acceleration, and acceleration equals force divided by mass. Newton's third law states that when an object pushes on another object, the first object gets pushed back and the opposite directly equally as hard. Projectile motion and problem solving. Solving problems for objects experiencing projectile motion is very similar to objects experiencing motion in one dimension. When use the same equations, but we have to treat problems like two separate ones, an x direction and a y direction problem. X direction, which is no source of acceleration, so motion stays uniform. Y direction is a source of acceleration, is gravity, so a negative 9.8 meters per second squared unless otherwise noted. Both dimensions share the value for time. Here's a video that does a great job explaining the process. Warning, this is the first of 4 videos, so it gets a little dry, but it's not the most entertaining, but he does a great job describing it, so stick with it. Unit 5, forces. Here are some subtopics that will be included that you need to understand for forces. Free body diagrams, inclines, friction conceptual, friction problem solving, centrifugal force, and weight. Unit 5, which is inclines. Here's a website that breaks down the parallel and perpendicular components and provides practice problems.